In this tutorial, we're going to import some simple vectors into the software and set up a double-sided job to create the conrod that you can see on screen. Then we're going to look at how we can reposition and offset XY position, how to use imported vectors for a two-sided job, and we're going to use a toolpath preview to prevent possible damage occurring whilst machining. So I'm just going to go ahead and close this file down, and then we're going to start by opening a new copy of the software and opening an existing file. So navigate your way through the video tutorials folders and go to the conrod files folder, and then we're going to click on the conrod.dxf file and then click on open. Then you can see it's imported those vectors in for us from that DXF file, and we immediately entered the job setup form. So the first thing that we're going to do is we're going to choose the job type. So we're going to choose a double-sided job, and then we're just going to change the job size itself. Now we are going to be working in millimeters for this, so just choose the millimeter option, and then we're going to change the width to 130 millimeters with a height of 60 and a thickness of 12 millimeters. And we're going to choose the Z0 position. Now we can either, when we're flipping the material from one side over to the other, we can Z0 off the same surface, so the material surface as is selected at the moment, or we can change that to the machine bed. Or we can have opposites, so basically the same side is always going to be the reference point for the Z0 position. Now this is always useful when using wood or planks of wood which may be slightly uneven over the surface, so we may not have planed the material first. But in this instance we're going to be using free machining aluminum, so we're actually going to machine off this material surface for both sides. We're going to leave the XY data position set in the lower left with the offset that is currently set, that was brought in with the DXF file, and then we're going to choose our flip direction when we're changing the material from side 1 to side 2. So I'm going to use the horizontal flip direction as is selected at the moment, and then I'm going to press OK, like so. So the first thing that I'm actually going to do is I'm going to center my vectors in the center of our material. So I'm going to press Ctrl and A on the keyboard to select them all, and then I'm going to come over to the transform objects and align the selected objects to the material itself. So how I do that is simply press this button here, and there is a keyboard shortcut which is F9 on the keyboard. So once we've done that, we can simply come out of that form, and I'm just going to deselect my vectors. Now you'll notice that the XY position actually was set in the center of this hole in the conrod here. Now I need to reposition that, and I may need to do that for different reasons, like the material comes with a specific anchor point for setting the actual tool in the material block. So I'm going to have to be able to reposition that XY offset into the center of our newly positioned conrod. Now I know that this rectangle that surrounds the conrod vectors itself was positioned exactly in the lower left hand corner there. So what I need to do is find out the difference in X and Y values to this new point where the rectangle is now located. Now how we can do that is we can utilize the draw polyline tool. So I'm just going to come into the draw polyline tool, and I'm actually going to anchor to the XY in the lower left hand corner there. Now then what I'm going to do is I'm just going to draw, and then when I get to this snap node, so you can see the icon change to the square with lines coming out of each side. That is basically me being able to snap to this node point here. Now if we look in the cursor position in the create polyline tool, which is up here, and we're specifically looking at the dx and dy values. So I'll just go back again, and you see that the dx is the direction movement in x, which is 6.5 mil, and y is 4 mil. So now I have that information, I can simply close this and go back into the job setup and just add that onto my offset. Now because we're working in negative values at the moment, we need to add on by minusing the 6.5 onto the minus 16 already. So I'm just going to put minus 6.5, then the equals key. That's then just going to add that for me. So I'm just going to add 4 to the y value, like so, and then I'm just going to press OK to accept that. And now you'll see that the XY position has recentered in the center of this circle here. Now, any imported vectors are going to be placed on the top side in our double-sided job. Now, how we can tell we're on the top side is if we just go over to here, you can see you can toggle between the top and bottom sides using this button here, but also the colour of the rulers around the outside. These are grey on the top side, and if we just switch to the bottom side, you'll see that they are a tone of orange on the underside, and also the icon changes with the arrow facing underneath the material block. Now we can also tell the flip direction by this icon here, so you can see that the arrow is going in a vertical direction, but meaning that we have to flip the material horizontally. And another thing you'll notice that while we're on the bottom side, we can actually see the vectors from the top side coming through on the underside, but they're not actually available for us to select. Now that's just something that enables us to try and position things if we are going to try and match up with certain parts of the top side and the bottom side. What we're going to do here is we're actually going to copy all the vectors that we imported onto the bottom side itself. And we can switch easily with the keyboard shortcuts between top and bottom sides as long as we're actually in the 2D or 3D view by pressing the numbers 1 or 2. So 1 will go to the top side and 2 will go to the bottom side, like so. Now we are creating a design which is exactly the same on the top side as is the bottom side. So technically we only need one set of toolpaths to create both sides. As long as we flip the material and the material doesn't get out of line whilst flipping, we can actually just run the same toolpath on the opposite side of the material. But to allow us to preview that in the software, we're going to have to copy these vectors onto the second side and create toolpaths on that second side so we can actually see exactly what it would look like in a simulation. So what we're going to do is we're going to press Ctrl A on the keyboard to select all the vectors, and I'm just going to right click them, and I'm going to choose this option to copy to the other side, like so. And if I flip to the bottom side, you'll see that we have those same vectors there, like so. So first thing we're going to do now we've got all the vectors ready, we're going to go over to the Toolpaths tab, like so. And before creating any toolpath, we should always make sure we check the material setup form. So I'm just going to check the set button there, and just going to go through these. So we've got a thickness of 12 mm. We're going to keep the offset as we've created it. We're going to be z-zeroing off the material surface, and the clearance looks good, and so does the home start position and the z-gap above the material. So I'm just going to press OK to accept those, and now we can start selecting some vectors for our toolpaths. Now, first of all, we're going to create a pocket, so we're going to pocket down 2 mm to leave this outer rim along the holes of the conrod. So we're going to select the rectangle, hold shift, and then select the outermost circle, like so. Then I'm going to go into the pocketing toolpath, like so. And we're going to have a start depth from the top of the material, so we're going to leave that at 0, and then a cut depth of just 2 mm. And then for this we're going to be using a 6 mm end mill, so I'm just going to go into the tool database, I'm going to go down to my metric tools, and I'm going to choose a end mill of 6 mm, like so. And what I'm going to do is I'm going to edit those parameters so that they're much more suitable for free machining aluminum. So I'm just going to press edit on that, and then I'm just going to edit a few parameters. So I'm going to keep the pass depth the same, and I'm just going to alter the step over to half of what it is at the moment, so it's going to put 20% in there. And I'm going to slow down the spindle speed to around about 3000 RPM. Feed rate at the moment is 60 mm per second. I'm going to slow this right down to 5 mm per second. I'm going to have a plunge rate of just 1 mm per second. And I'm just going to press OK. Now what that's done is that's just temporarily edited the values for that tool. So once we're happy with that, I'm just going to go ahead and choose the strategy that we're going to use to clear the pocket. So I'm just going to keep this as an offset strategy. And then I'm just going to go down, I'm going to choose to ramp the plunge moves over a distance of 16 mm. So I'm just going to type 16 mm there. That just helps protect the tool as it's going down to its cut depth. And then I'm just going to give this a name. I'm just going to call this pocket 2 mm, like so. And just press calculate. And we can preview that if we like. So there you can see what that's done there. Now we do need to do the same thing for the second side. So I'm just going to go ahead and just press number 2 to flip over to the bottom side. And I'm doing this obviously just so we can preview this in the simulation. So I'm just going to go ahead and quickly just recreate that same toolpath. So everything should be the same, even the edited parameters, as you can see, like so. So all I need to do is just check the ramp plunge moves and just call this pocket 2mm. Again, calculate and preview. So it should look exactly the same as the top side. So I'm just going to press the number 1, it's going to go back over to the top side. I'm going to go into the 2D view to create our next toolpath, which is going to be this vector here. Now this vector is here to create basically a pocket which is going to be used to lighten the whole weight of the conrod itself. And we're going to do this again on both sides. So I'm just going to select that vector and press close and go to the pocket toolpath, like so. Then we're going to have a start depth from the top of the material again, and just going to cut down 4mm. So just make sure that we put that in there. And I'm just going to use the same tool, the end mill of 6mm. I'm just going to press edit to make sure that those edited parameters still exist, which they do. And I'm just going to use the same strategy. I'm going to ramp down of 16mm, like so. I'm just going to change the name of this to something more relevant, like lighten pocket, and then press calculate and preview, like so. Just going to do the same again on the second side. So select the vector, go into pocket, everything should be the same, just make sure, like so, and ramp and change the name to lighten pocket, like so. Just calculate that and preview that again. So you see that now we'll have something that looks exactly the same on both sides, like so. So I'm just going to go back up to the top side, and next I'm actually going to pocket out the holes for the conrod itself. So I'm just going to shift and select the second hole there and press close, go into the pocket toolpath. Now here I can actually pocket all the way down to the bottom of the material, so I can create, for simulation purposes, just the one toolpath here. Now I could actually use a profile toolpath here if we were using a vacuum hold down table or some other form that secures any waste material from being flung out or causing any damage to the tool or the actual part itself. So I'm just going to presume we're not, so I'm just going to here just pocket out that material and presume that we're just going to be extracting all that waste. So let's change the cut depth to 12mm, which is the thickness of the material. Make sure we've got that end mill 6mm selected and the edited parameters are still the ones that we've chosen, like so. I'm just going to scroll down and I'm going to make sure that we've got the offset strategy selected. Ramp the plunge moves 60mm. That value should actually still be there. And we're just going to call this pocket holes, like so. Calculate that and then we can preview. You see that's gone right through to the other side of the material, like so. So we don't actually need to create that one on the other side. So next we can create the cutout path. So let's go into the 2D view and select the vector for the cutout, like so. Just close that. And then we're going to select the profile toolpath. So we're going to start the cut from the top of the material, so 0, 0, and we're going to cut down to 12mm, which it currently is set at there. So I'm just going to change that. Now we do have, as you can see, the end mill of 6mm selected currently, which is good, but does it have the same parameters that we specified for cutting free machining aluminum? So let's just check the edit box, and you'll see that these are actually the parameters for the standard 6mm end mill. Now unless we add the tool for a specific machining of aluminum, we are going to need to specify these parameters again because we've not yet used the profile toolpath, so it doesn't pass on the edited parameters from the pocket toolpath. So we are going to need to either add the tool in or edit these parameters here. So I'm just going to go ahead and edit these to a step over of 20%, a spindle speed of 3000 RPM, and a feed rate of 5mm per second, and a plunge rate of 1mm per second, and press OK, like so. Now we are going to be cutting this conrod out, so we want to machine on the outside of the vectors. It's going to scroll down, and we're going to add tabs to this because we don't have, or we're going to presume we don't have anything to hold it down with at the moment. So I'm just going to add some tabs to this with a length of 4mm and a thickness of 4mm. So I'm going to press the Edit Tabs button to place these. So when it shows the tick symbol, I'm OK to add. So I'm just going to add them to those places there, like so, and press Close. And I'm just going to scroll down, and I'm just going to add a ramp to this toolpath of zigzag, which is the same as we had in the pocket toolpath. And we're going to ramp over a distance of, again, 16mm. So I'm just going to call this Profile Cutout, like so, and then press Calculate, and then we can preview the toolpath. And then we have literally a whole conrod finished. Now, if you notice straight away, there's a problem here. This is the beauty of using the preview toolpath form. You'll see that the actual profile cutout itself has actually crashed into the wall that was left there by the pocket. Now, it may only be minor, but when you've got a tool that's machining nothing around here and then it suddenly collides with a wall of metal, that's going to put some strain on the actual tool itself. So it is possible that it could actually break the tool itself. Now we don't actually want to do that. So what we're going to need to do actually is we're going to need to edit that pocket vector. So let's just close the preview toolpath form. I'm going to go back over to the drawing tab, like so, and I'm going to go into the 2D view. So what we need to do really is create another boundary for the outside of our pocket when we pocket down that 2mm. So that would be this vector here. Now we need to make sure that there's at least the diameter of the tool space in between the conrod and the rectangle itself that we're pocketing. Now, rather than trying to measure roughly where that is, we're actually going to use the object bounds that comes with the Smart Cursor feature to create first a rectangle that fully surrounds the conrod, so we know exactly the size that we need, and we're just going to offset that by the diameter of the tool, or slightly more. So with that selected, I'm just going to press the delete key, and then I'm going to do the same on the bottom side, like so. I'm just going to return to the top side, and then what I'm going to do is I'm going to press F4 on the keyboard, which brings up our snapping options. Now you can also access this through the edit menu up here, and what we're going to do is we're going to turn on the object bounds, which is under the smart snapping options here. And what this will do, this will bring up blue lines now, which are basically the object boundaries of any objects that we place our cursor near. So let's just press OK on this, and I'll demonstrate this for you. So I'm just going to go into the Draw Rectangle tool. What I want to do is I want to draw a rectangle which surrounds literally the object boundaries of this conrod. So what I'm going to do is I'm just going to hover near here. So you'll see that straight away now that blue line is bringing up the object boundary line of this outer conrod. And then what I can do is I'll come over to here, and you'll see that the vertical blue line is now appeared. Now, because they're both blue, that means they're both object boundary lines. So I can be assured that if I start clicking here and then dragging outwards, I'm going to be passing through both points here and here exactly. And then I'm just going to pull it upwards until the blue lines meet again. Now you'll see that'll be here like so. And then all I need to do is simply let go of the left mouse key, and that'll create the rectangle perfectly to size around my conrod. So I can close this now, and I can simply just go into the Offset Selected Vectors tool, and we're going to offset that rectangle that we've just created outwards around about just over 6mm, so just about 6.5mm. And we're going to create sharp corners. We're going to delete the original vector that we created, and we're going to select the new one. So let's press Offset, and that's now created our new vector. So we can close this, and we can now right click that vector and copy to the other side, and we can just go ahead and edit those pocket toolpaths. So let's go into the pocket 2mm toolpath, and you'll see that those two original vectors are selected, and you just shift and select that new vector, and if we just scroll down, recalculate that, and then if we do that again on the second side, so I'm just going to go into the 2D view there and press the number 2, go into the pocket by double clicking. You see that those two vectors again are selected. Shift and select that outer vector we've just created and recalculate. And now if we reset the preview and preview all sides, we should have a nice collision-free toolpath, as you can see there, like so. So it's definitely well worth previewing all your toolpaths to avoid any hazardous situations. And now we have the perfect comrod built on two-sided machining, like so. So, as I mentioned, we only really need to create the one set of toolpaths to create the toolpath for both sides of this comrod. So we'll just close this and go back over to the top side by pressing the number 1 in the 2D or 3D view, like so. I'm just going to spin this back round, like so. So we only really need to create these 4 toolpaths, and the 2 of them we only need to run on the one side, which is going to be the pocket, to pocket down 2 mil and to lighten the pockets. The rest can be ran on the other side, so that would be the pocket holes and the profile cutout, because both of those are actually cutting down the full depth of material. So there's only two toolpaths that you actually need to run on the opposite side. Now how we would save that out is we would go to Save Toolpaths, and at the moment it's selected all of them because we are using the same 6mm end mill. However, what I would do is I would just deselect the ones that I don't want, and I would select the output all visible toolpaths to one file, as that was already selected in my options. It may not be for you. So I'd choose the pocket and then lighten the pocket. So I'd do those together, save those out with my selected post processor, and then I'd run that same one on the other side, and then I'd also run the pocket holes and profile cutout after those as well. Now you can run the toolpaths in any manner of methods as well. You could even create the same toolpaths both sides, but actually use half of the material for the pocket holes and the profile cutout. The choice is totally up to you. And with that comes the end of this tutorial, so thank you very much for watching.